Here we go is right. Okay, so one aspect that I was informed is converting to joules per gram. Is that correct? Oh, but taking kilojoules to mole, converting to joules per gram. That's what I meant. Okay, so again, it's one of them aspects. This is not that easy being on this side of the desk. Again, that's how we learn. That's how we grow. Again, it's not a derogatory comment against anybody. So one of the things, I see some of you actually have those charts in front of you. You must have printed them off. Okay. So we'll do this. I just want to show you a different example so then you'll actually know how to do this, because it can go in both directions. Okay, so what I mean by that is as follows. So if we look at the element cesium, okay, the heat of fusion, there's a vaporization. I better make sure I get the, yep, heat of fusion, okay? This is what it is in joules per gram, 15.72. Well, 15.7. But on your table, okay, can someone tell me in kilojoules per mole, well, I guess I have it here, for cesium, it looks to me like, is it 67? No, that's heat of vaporization. Which one do you look at? We want the enthalpy of fusion. It's given in kilojoules per mole. Is for cesium. Is it 2.0? Okay, so this is how you do it. So if we've got 2.087 kilojoules. Oh, did I look at specific heat?
Yeah.
Okay.
No.
Cesium.
You're right.
Yeah, 2.087. Entropy, and heat of fusion, it means the same thing. Okay? So 2.087. Now remember, this is our target here. Okay? So to make this conversion, we can with this known value because this is a known substance. Okay? So what you would do, you can write it as a fraction like this on top. It's maybe just a little more confusing. Because you do that probably in your Algebra 2 class quite a bit, where when you have fractions where they cancel each other out. Does that sound correct? Okay. So this, using your dimensional analysis, okay, is really no different. We got a kilojoule per mole. Okay. So the next thing to do is maybe get rid of this kilojoule to get it into joules. Okay. So then, where would the 1,000 go, though? Okay. See, now this is why showing your labels as you go is so important. You would not want to do this. That wouldn't make any sense, would it? No, it would not. So for every 1,000 joules, you have 1 kilojoule. Okay? And again, that's how we grow and that's how we learn. Okay? All right? So, we're just all trying to move in the same direction. So these cancel, right? Now we've got joules per mole, so we're one step closer. So remember, this is a known substance. So how could we cancel this mole out on top and yet get this on the bottom? It goes all the way back to chapter 3. Exactly. Grams of what, though? For cesium, which is, again, for me, sometimes it's a little tough reading on 32? 32.905. Okay, 132. Okay, so even if we put just 132. and that's grams. So this mole cancels out that one. So now, if we take 2.087, and if we take that times 1,000,
Could you have 130, 30 at the end?
It's all right.
you get 15.8, okay? This was our target, 15.7, so probably somewhere here in the rounding, okay? Okay, if we put 133, that might get a little closer then. That would knock that number down to perhaps 15.7.
So
Okay.
this, you actually put something under it on the first step.
This here?
The first step.
Yeah, it's from, because on your table it's measured in kilojoules per mole, right? Okay. So technically, this is not wrong. It is maybe just one of those that's just a little confusing. Because what happens is it's just like taking 1/3 times 3, which is 3 over 1. It's just an inverse, okay? So in this case, this still cancels that out. That still cancels this out, and you're in joules per gram, which is what you want, okay? So that's how you convert the two.
So that's all we gotta do.
That's all you got to do. So keep in mind, we did a little experiment here earlier, and sorry, thanks for being a good sport. Sometimes when you ask someone on the fly like this, kind of like, yeah, I don't know. Just think, one of the things that, for those of you who go off onto technical school or college, and you probably have to go through, I don't want to call it internet services, but technical support maybe. They're going to say, okay, here's your login information. What do you want for a password?
Your name.
You could, but highly unlikely. Okay? But it's just one of them things to where you get asked something on the spur of the moment. It's kind of like, this should not be this difficult. I need a password. Okay, well then, I would recommend, well, go ahead. I would just recommend not doing that. Okay? All right. So keep in mind that should you be given a story problem that has these 5 steps in here, okay, you cannot do these problems with that. Even though this is a heat of fusion, why can't we use this? Joules over grams. Because, okay, because the mass is measured in grams, not moles, okay? And also the specific heat is joules per gram degree Celsius. And that's why this heat of fusion has to be in joules per gram. You have to have the same units, okay? So we're just providing just another step that you have to do, because this helps you in your problem solving skills. Like it, don't like it, that's the approach that we're taking. Okay, so anything in those 5 steps that needs to be done in order, okay? Because if you're dealing with a metal like on the board yesterday, or if you're calculating how much energy it is to change water from ice to steam, you don't start out with steam first. That would just be silly, I think. What's maybe a better word, a synonym than silly?
Goofy.
It might be goofy. Sure, we'll go with goofy. Okay, so just a moment, because we don't need to be recording all of this. I'm just going to hit pause. Okay, so just to hold that thought. Okay, so can someone just please provide me, you just tell me a number.
1.
Okay, water's molar heat of fusion is blah, blah, blah.
Yeah.
Okay, so when it says calculate the energy, that energy has to be measured in one of two values. That's one, and kilojoules is the other. Okay, so since you are given a heat of fusion in kilojoules per mole, would you have to go through this process? No.
You should though, because you're a given gram.
Okay? Because you have to remember, this is also a known substance. Okay? So, anyway, what number would you start with in number 1?
6.0.
You could.
Or 7.
If you're given a mass in the problem, that's probably the best place to start. There again, that comes with experience. Okay? So if we got 7.95 times 10 to what? The fifth? Okay? So now, you could write grams of ice here, but really what substance is that? Yeah, H2O, because it's a known substance.
4.18.
Okay? So, in this case, okay, since you are given this in a value of kilojoules per mole, you can't use these formulas. It's something very similar. The reason is, okay, this heat of fusion that you use in these problems is measured in what? Joules over grams. You're not given joules over grams, okay? So remember, when you're measuring these quantities, it's either this or that, okay? So when you're given this molar heat of fusion, which is kilojoules per mole, okay, one of the things that you can do first is either get rid of this gram, which is probably the best thing to do, and how could we do that because of this known substance?
18.02.
Right. So for every 18.02 grams of water, you have a mole of that water, okay? Because remember, your heat of fusion is given in kilojoules per mole. So now, these grams have canceled. You're in moles now. So how can we get rid of that mole to give us one of these two accepted values for energy? That would make things a lot more time-consuming. You could. But remember, how is heat measured? In what or what? Did I say temperature? I meant energy. Joules or kilojoules? Close. Put a kilojoule up there. How many kilojoules? No. 6.009 given in the problem. So 6.009 kilojoules for every one what? Okay? These moles have canceled. You're left with kilojoules, which is one of the accepted values for calculating energy. In this case, heat energy.
So that's your answer. This is heat fusion?
This is your heat of fusion right here.
That's your answer.
No, but
Once you multiply that across, then that's your answer.
those
So
given
it's-
values
So
on the
what problem over there did we use?
1, 3, or 5.
Of these,
Yeah.
it would be this one, but the only reason or way this works is if this heat of fusion is given in that value.
So could you transfer the 6.009
You can use 1, 3, or 5.
to joules?
What's your temperature range?
Don't have one.
Yeah, because you don't have a temperature range, so that's why you can't use these. Okay?
How do you know if you're going to use like this or the other one?
Okay, can you be a little more specific with that?
Use those equations and joules.
This is what you're doing if it's a 5-step problem, all these. But if you are given a variable that's measured in joules per gram, yeah, by all means, use number 2 and number 4. That would make things a lot easier. Okay? Because look at, well, once you multiply this times this and divide by 18, your answer is going to be given in kilojoules. And that's it. Yep. Okay.
Can we do one that use all 5 of those equations?
That's what you're doing in problem 3.
Is this? We don't still do tomorrow.
Well,
He told us it'd probably be due on Monday.
I don't think Mr. Wagner
Call him
said.
right now.
No,
Yeah,
because
yeah.
we discussed
Like
something
that,
different.
like
He actually did say that.
I'm not that far away. All
He
right.
told us yesterday, I think I'm gonna move him to Monday because we
said
can
they'll
get
probably
started
be
on
due on
yesterday.
No,
How much?
because the conversation we had was just a little bit different than that. We thought maybe at the end of class on Thursday.
He told us Monday.
He did not.
He did.
And I'm not going to call him right now because he's busy supervising.
You know,
Yeah.
Even ask this girl Presley, she ain't gonna lie to you.
he did say.
So there's questions on number 2. It should say something along the lines of, given that a substance has a molar mass of 259 grams per mole, okay, and 71.8 grams of the substance absorbs 4.307 kilojoules when it melts.
So would that one be like number 1?
Well, we don't have
No, but
No.
they give you a grant, or
Okay.
they give you a mass. not-
They do give you a mass. So calculate how many moles are present in the sample and then the molar heat of fusion. It's a two-step process. So the clue is, okay, calculate how many moles are present. So how could you do that with this unknown substance if you're given 71.8 grams of it, but you also know the molar mass of it?
You're gonna have to use some of that formula.
No.
Well, no, you gotta
Do something like
You
this.
gotta do like what you did in step 1, but then you use your mass.
And that's where you stop. Okay? Because it says calculate your moles first, right?
Yeah.
Okay. So going all the way back to chapter 3, last fall. Say that again. Right. So if we are given 71.8, okay, and this is grams of an unknown substance, typically you'd put that here, but we don't know what this substance is. But you know what the molar mass is. So how can we change this to moles first, where it says calculate your moles first by what we said correctly in the back row?
No grams to mole. Put a little 290 or 259 on the bottom.
And you're correct, but why would you do that?
That's how many grams you got.
Right, because we want to find the number of moles first. Okay, 259 point, okay, grams for every mole. So now these grams are gone. Now you're just left with moles.
So then you times.
So now notice you have half of the information you need now. Because how do we calculate heat of fusions? Or what's the label for them? Sorry. Joules over grams or kilojoules per mole. Well, if we get the number of moles here,
It gives us kilojoules.
0.28.
so this answer goes here in moles, and then in the back, you're also given 4 something kilojoules, right?
0.307.
So then whatever this is in moles goes on the bottom. Then you would divide that out, and then you'd have your kilojoules per mole. That's your answer.
But you gotta write your moles too for equilibrium.
So I know what'd you get. Yeah, that's what I get.
Okay. then what I want you to, someone look at
Is that just kilojoules, or do you do kilojoules over mole?
kilojoules over mole. Yep. And you should get an answer between 15 and 16. Okay? So when you look at, for instance, what could we say? Number 5. Okay? So what does number 5 say?
How much heat energy will be needed to make 25
So the entropy of fusion, which means heat of fusion, has to be labeled in 2 things, either kilojoules per mole or what? So now, if you are given a value that's joules per gram, can we just use this formula? Sure. Okay. The reason being is because you are given however many grams of that there is, which looks like 25. Okay, 25 point something. You can separate that out on your own. Okay? So if you know the amount of joules per gram, okay, joules over gram, which means what, 162, or you can say Q equals mass 25 times 162. Here you're just showing that these cancel out, right? Or no, that doesn't. That's not what we're looking. Yeah, those cancel out because to measure heat, it's either in joules or kilojoules.
So we're using like Q1 to figure that one out?
No,
Q2.
this one. Because you're doing the exact same thing. You're just representing it in a different manner. How do you label that? How do you measure heat energy? No. Just joules. Okay?
Is number 8 a 5 step?
Maybe. Is it talking about water?
Yeah, it's talking about H2O.
Okay. So number 8 and number 3, they're the same thing. There's just different values. Different values in grams, I mean.
Wait, so Q1 is starting as a solid, right?
That's correct.
Then it goes to a...
Okay? So that's what you're illustrating when this diagram was up on the board yesterday. Okay?
So Q1 is a solid, Q3 is a...
So here you have this diagram. Here you're starting at, okay? And this could very well be, let's say, -10. Okay? Doesn't matter where this corner is. We know that as we're going up, eventually, when you get to this point, what's going to happen? Okay? So you're adding an amount of heat, and however many grams it is, which 46, that seems to ring a bell. No.
46 grams of H2O.
That's number 8. I don't care. I was just looking at number 3 because they're the same type of problem. Okay? So you got a mass of 24.5. Okay? So then, okay? You're getting a little ahead of yourself, which is fine. It doesn't matter which order you put these in. But is it -7? Is it -7? It's +7.
7 degrees Celsius.
Okay? Now, so I put -10 there, so in the problem, I'd say -7. Okay. Because, okay, so -7, -6, -5, -4, -3, -2, -1, and then 0. So it moved a total of 7 increments. Positive, not negative. Okay? Then what is the specific heat for water in its solid state?
Wait, how do you get 32?
Because it's starting out at -7, right?
32.
It's moving up 1, 2, 3, 4, 5, 6, 7 times. That's why it's +7.
2.06, right?
That's not
Yeah,
what's in a solid, is it?
32.
CP of solid is
Oh, that's
Solid.
Celsius.
Solid water is 2.06.
Will that be up there for the test?
And then you
No,
multiply
it would be given in the problem. It just won't be up here. Okay? So then someone has said that this plateaus. You're right, because what's not happening in step 2 that is in step 1?
It's not changed.
It's not doing this. Okay? All right. So then in this case, now once we reach 0, this is starting to liquefy, which means the mass is still the same. Okay? And then what is the heat of fusion for water? Okay? So then we look at this, it says 334. Sorry, I didn't hear that.
Do you need that packet to know that, or not?
This here? Someone had already asked a similar question. No, you don't need to know that. It will be given in the problem. They're just in random orders. You just have to know what it means for that state. Okay? So then, now that we have melted this, okay, now we're going to go all the way up to where this is going to start to turn to a gas.
Right there.
Which is right here. So approximately how many increments would that be? That's right here.
It would be 145 degrees. 145.
Too much.
Are you talking about when it's boiling?
Right. When does water start to boil?
45 Celsius.
Man, your pressure is really, really low then. 100. So between this point, which is the melting point, this point, which is the boiling point, there'd be 10, 20, 30, 40, oh boy, 50, 60, 70, 80, 90. So there is 100 increments in there.
Hey, Mr.
Yes.
Is that VF down there supposed to be HF? The 3
Oh yeah. I'm thinking velocities. Yep. Maybe it said HF up there earlier. I don't know. All right. So then, okay, the mass has not changed because you can't really change the mass. I mean, eventually, if you boil enough of that off, it'll change. But now you still have 24 and a half. Okay. Then what is the specific heat for liquid water? 4.184. Okay? It is. No.
Why, it's gonna be 100 then?
Oh, well, okay. 24.5. Okay?
What happened?
Yeah, because this is where it started to climb again. 10, 20, 30, 40, all the way up to,
Always 100?
for our purposes, yes, but you'd be given a melting point. Like yesterday, what metal was it? Was it nickel?
Iron.
Oh, iron. So then eventually you can add enough heat that iron's going to be bubbling. So because that's how you make steel, you have to smelt or melt that iron down and combine with other substances to make, whether it's Bessemer steel or stainless steel or whichever. What about Bessemer?
What was his name again?
I just know it was Bessemer steel. That was a long time ago, in late 1800s. Well, he the two probably never met. Okay.
That's a shame.
Did you get 1878?
You know, John D. Rockefeller?
Yeah, you made Standard Oil.
You could say that.
I made oil standard, whichever way you want to look at it.
First $1 million.
Okay. All right. So now we're not adding any heat anymore because it's starting to bubble. Okay. So then here, 24.5. What's the heat of fusion for steam? 2,260. It might look like there's a decimal point there, but there's not. So 2260. Okay. Then this eventually goes all the way up to where we're making steam.
I didn't add that last on there.
Okay. So then again, the mass has not changed. Okay. The specific heat for steam is 2.02. And then what is your last temperature range? And 45 is right, but why is it only 45? So we're already at 100, and it's going up here to 145. 100 minus 145 gives you that 45 value. And for each Q, which there's 5 of them,
What's your right little Q4 there for that second number? I can't read that.
2,260?
this one here, oh yeah, 2260. So these all have a specific number. Then finally Q total is all those added together.
This makes a little more sense than what old Mr. Wagner was teaching the fellers.
Well, it's nobody's fault, okay?
So would that be?
I'll take the blame.
That everything's in joules, okay? So this is why, okay? You have this is labeled in grams. This is labeled in degrees Celsius. This is labeled in joules per gram degree Celsius. That gram cancels that one. This cancels this one. You're just left with joules. Then you could say in this step, grams, and then just as joules per gram. They cancel. Everything's in joules.
What's the heat for steam? 145.
Heat of fusion for steam is 334 joules per gram. Oh, I'm sorry, for vaporization, yes, 2,260. Yep, it's written up here. You just can't quite see it probably.
Did you get, so you just add them all together then?
Yeah, add them all together.
You get 76,384.
Oh, it's 45.
Did you measure that?
One of the things we just said, keep in mind that this first problem is probably the most difficult because this content is new. It's not that it gets easier, you just get more familiar with it. Okay, so we'll do our best. We'll see how things go tomorrow.
It's something.
Yeah, it's something. Okay, if you have problems, please just ask. All right, we'll catch up to you next time.